Good evening, everyone. Very good evening. Am I audible to you all? Okay, I hope I'm audible. Okay. So, guys, in yesterday's class, we have seen what is upcasting, downcasting, and when you will get class cast exception. When you will get class cast exception. So let us revise it once again and let us go further with one design today. Okay. So let us go for your upcasting and downcasting. Okay, assume there are two classes. Okay, parent class as well as a child class. Parent class as well as child class. Okay, and now there is an easy relationship going on between these two classes. There is an easy relationship going on between these two classes. This class name I can take it as a parent class. This class name we can take it as a child class. So if you want to do upcasting, you can do directly for the directly or using the parent reference. So parent P is equal to, no, I didn't send you guys the notes. Okay, now today I will send you. Okay, so yeah, I'll send you today. Yeah, some network issue is there, so I was not able to access the application. I don't know what happened, so I will send it today somehow. Okay, so let us go for upcasting. See, there are two ways of doing upcasting. So parent P is equal to new child of no argument constructor. So this holds the reference. The completely this will hold the reference of an object. So the reference will be stored in variable P. This is one way of doing it. Another way of doing it is you can just create an object for child C is equal to new child of no argument constructor. Okay, so after this you can go for parent class. Parent P is equal to variable C. This is also called as upcasting. So reference of the new keyword will be stored in C. So C reference, okay, C address will be stored in variable P. C address will be stored in variable P. Okay. So these both are called as upcasting. These both are called as upcasting. Both the ways are fine. Either you can directly give the whole instance of the child to variable P, or you can store the instance in a reference variable, and then through the reference variable you can give the address to variable P. Both are the same. Okay, both end up in the same place. Okay, same practically thinking, same value. That is, if you're doing upcasting, child reference will be converted to parent. Here also child reference is converted to parent. Here also child reference is converted to parent only. Both ways are same. Okay, you can either you can go within one line, you can go for this, or within two lines you can go for this also. Okay, so this is called as upcasting. So after upcasting, we can access only the members of parent class with the parent reference. With the parent reference, we can only access parent class. But child class will not be able to access. After upcasting, we will not be able to access child class. So in order to access child class, we will be downcasting. Downcasting, while doing it, we converting parent type reference into child type. We'll be converting parent type reference into child type. Okay. So let us see how we can do it. So downcasting is done in the following way. So this is upcasting. Downcasting is done as, there is two ways. Child C here, for this way I am telling you. This is upcasting. Now downcasting for this is child C is equal to P. child C, because the variable is of, I mean, this whole thing contains the address. So whole instance you are storing in variable P. Whole child instance you are storing in variable P. So child C is equal to P. This is also correct. Okay, this is also correct. You have done downcasting here also. And here also it's the same. How? Here, while converting, this is of parent type. Okay, this is of parent type. So here we have to use typecast operator. Okay, since we are converting it to child type, parent we are converting to child type. Here it's a downcasting, and compiler will not do it by default. So you have to go for converting it into child, child of P. Okay, directly you can't do, you have to do it with the help of the typecast operator. Downcasting is not done directly, but it has to be done by programmer with the help of typecast operator. And now variable P will be converted to, that is parent reference P will be converted to child type object. And after that, this child, this variable P, whatever the address is there, first it will be converted to child, and it will be stored in it, the address will be stored in the child variable C. Address will be stored in child variable C. This is how you do downcasting when it is this. Okay, so here we have done a upcasting parent P is equal to new child of no argument constructor. So directly direct instance only we have given for the parent. But while downcasting, you have to store the address in variable C, no, that is child type, no. Yes. So here we have gone to your child, okay, child of P. Why? Because it's a downcasting and your compiler will not do it by default. Okay, so downcasting, we don't know to which child we have to do, so that is why we have to do it by ourselves. So C is equal to child of P. Yes, Sanket, for the this one, for the next one it is correct. So for this way we can already, we have declared child C. Child C we have already declared. So we will just initialize. C is equal to C is equal to child of P. C is equal to child of P. C is equal to child of P. So this is what we call it as downcasting. Downcasting. Okay. Now, you have to understand about one operator called as instance of operator. So why you have to understand about that instance of operator is because here now we will be doing one program, okay? One program with hierarchical inheritance. With hierarchical inheritance, that too with the help of instance of operator also we'll be getting the output. So we'll be going for instance of operator now. So now let us go for an operator. This is one of the miscellaneous operators. This is one of the miscellaneous operators. Okay. So instance of, everything should be in lowercase. Instance of is an operator. Okay. Specifically telling it is a binary operator. It is a binary operator, and it is also a keyword because everything is written in lowercase. And this instance of operator is used to check or is used to test if an object is of given type. It is used to test, it is used to test if an object is of given type. If an object is of given type. Okay. And and here you'll get to know later what this is. Now, the return type of this instance of operator is Boolean. Return type of instance of operator is Boolean. Okay. So here in the syntax of instance of operator, okay, if the specified object is given, okay, if the specified object is of given type, then the operator will return true or the operator will return false. Okay. So let us understand this with the help of syntax. So syntax to use instance of operator. Here we have to first write the object reference. You have to first write the object reference, then instance of keyword, then instance of keyword, then the type of object you have to mention here. First you have to write the object reference, then you have to write instance of keyword, and you have to just write the type of the object. What type of object reference is this? Okay. So suppose if you're creating an instance of string, okay, so new string, an object reference. Okay, this also stores reference. Directly reference variable you can mention, or this instance you can mention, both are same. Okay, now this new instance, okay, I mean the new string of no argument constructor, instance of object, instance of object. Okay, here string is of object type, string is of object type. Okay, voice is breaking. Am I audible to you all? Everyone, am I audible to you all? Okay, guys, I think Saurabh is having some network issue. Okay, clear. Okay, guys. So here, the syntax of instance operator is, no, there is no space between instance of. It's a keyword. Keyword means it is continuously joined. There is no space in between instance of. No, there is no space. So here you have to mention the reference of the object, and here you have to mention the type of object. See, string is also child of object. String is also a child of object. Yes. So here instance of operator will return true. Instance of operator will return true. For instance of operator to return true, there must be a condition, that is the two, whatever the object reference you're writing and the type of the object you're writing, there should be an is a relationship. There should be an is a relationship present between the object reference and the type of object. Between the object reference and the type of object, there should be an is a relationship. Okay, is a relationship. If is a relationship is there only, if there is an is a relationship between this whatever the object reference and the object you have mentioned, if there is an is a relationship, your instance of operator will return true. But in case this reference variable, this doesn't belong to the type of object, that means if this object reference is not having a is a relationship with this object, okay, then we will get false. So whatever the object reference you are mentioning and whatever the object you are mentioning here, both should be of, both should be of, both should be having a is a relationship. Both should be having is a relationship. Okay. If there is a relationship only, instance of operator will return true, or else it will return false. Means vegetable extends tomato, no. Vegetable extends, no. Tomato extends vegetable. Why extends came here? You can mention instance of tomato here, like new tomato you can mention. Okay, it's an instance of vegetable. It's an instance of vegetable. Okay, you can go for that. See, it's not mandatory you have to mention parent type only here and you have to mention child type reference only. No, here you can mention parent type reference also. Here you can mention child object also. It's okay, wherever whatever you want you can do. But the thing is, whomever you are writing here, no, both two different elements, they should have an easy relationship. They should have an easy relationship. Okay, so let us understand this practically. Okay, let us understand this practically with one small design which we'll be doing now. Okay. Okay, so let us have the design now. So the design we shall have, that is your sim. Okay, first you will have your class sim. Okay, sim class we shall take first, and sim will have two children, that is Airtel one as well as Idea one. Now we shall go for a inheritance, that is hierarchical inheritance. Okay, we shall go for hierarchical inheritance. And now the name of the class, we will name it as a class sim. Okay, sim will have sim number, network type, and service provider. Service provider. Okay. Then we'll have Airtel class here. Airtel. And here we shall go for class idea. And Airtel will have its own attribute, that is color of the SIM. Idea also will have its own attribute, that is color of the SIM. And meanwhile, they both will have the method, that is SIM details method. They both will have a SIM details method between them. Okay, this will have also one SIM details method, and here also will have one SIM details method customized. So we'll have one SIM details method. And here also we'll go for SIM details method. Choice number may be attribute for SIM. What is this? Choice number may be attribute for SIM now. Choice. No, no, no. Choice is not an attribute for the SIM. It's just an option. It is given to the user. Okay, it's for the user. Choice is for user. And only SIM attributes are SIM number, network type, and service provider. Airtel attributes are SIM number, network provider, network type, service provider, and color. Idea attributes are SIM number, network type, service provider, and color. Okay. So here we are going with the hierarchical inheritance. Okay, hierarchical inheritance. Hierarchical inheritance. Okay, and here we will also use instance of operator. Instance of operator will be using. Okay, so let us just take a snap of this for the future reference. Okay, so we shall go for your class and for your project. Okay, Samsung gadget yesterday we have done, no? Okay, so yeah, I didn't send your notes. Yes, I was clicking on send button, it was not working actually. So we'll send it today. We'll try to send it today. So after this, we have done Samsung and something else also. Okay, so we have done class that is veggies carrot class also we have done, upcasting downcasting both we have done, and a class apple also we have done. Okay, and yeah, so Samsung mobile also is done. Now we shall go for first we will go for one driver class. Okay, we shall first go for one driver class. Okay, so driver class name we can just take it as a sim driver, because everything will be writing in the same file. Let us take it as a sim driver, and we shall take an input from user. So import java dot util dot scanner class, and here go for main method, and we'll create an object for scanner class. Scanner AC is equal to new scanner of system dot in. Okay, now our sim driver class is ready. Okay, sim driver class is ready. Now what is our next task is we have to create a class called as sim. We have to create a class called as sim. So class sim. So we will create a class sim now. So inside a class sim, we will have attributes. Sim class is already taken. Where? Let me check here. No, it is not taken. It is not taken, we shall take it. So sim is there. We did the program already. No, if there is any class name with the sim, no, it would have shown error. So if it's not shown, it's okay. We are doing in different package. See, we are doing in relationship package. If it is done in oops, no problem. Okay, whatever, no problem. Here, because we are doing in different package, no, so it will not throw any error because that package classes are different. This package classes are different. Okay, it's in a different package, so no worries. So sim will have sim number. So sim number we can go for long sim number. Then comes string network type, string network type, and string service provider. Okay, sim. We have three attributes: sim number, network type, sim number, network type, and service provider. We have these three attributes. Now let us go for creating a constructor now. Okay, let us go for creating one constructor. Okay, we shall make this class simple and we shall make one constructor here. We'll create one constructor. Source, shall go to source, generate constructors using fields, and go for generate. So currently we do have one constructor now. So long sim number, string network type, service provider, and here there will always be a supercall statement. There will always be a supercall statement calling the object class. Okay, object class, calling object class constructor. Now here, now here we have a sim uh, details. Okay, and we are initializing it with the local variables. That's all it is done. That's all in our class sim. It's very easy. That's all in your sim class. So after this, we shall create one more class, that is our class Airtel. Class Airtel. Airtel is a normal class, and in case if you want to make it as a child of sim, so you have to extends. So to write extends sim. Class Airtel extends sim. So since there is already a constructor in the parent class, your child class is urging for a constructor, so we shall create it. And one more thing is here in this child class Airtel, we have one individual attribute for the Airtel, that is own attribute, that is color. Okay. So while you are mentioning all the attributes in the constructor, you should also mention at the end, you have to also mention the color. Okay. So here, but in a supercall statement, you have to mention only these three attributes because parent class constructor, okay, because parent class constructor only contains these three attributes. Parent class constructors only contain these three attributes. So only sim number, network type, and service provider should be written. And lastly, this data, that is string color. Okay. Okay, lastly the string color is there, no, that also has to be initialized. So here we'll be initializing it. This dot color is equal to color. This dot color is equal to color. Okay. Okay, this is our Airtel constructor, and we shall have one more method. Okay, one method we have, that is our sim details method. Public void sim details method. Okay, guys, just a minute, I'm getting a call. Excuse me, guys. Yeah. Okay. So now what we are doing is, okay, we have created a class child Airtel. Okay, we have created one child class Airtel which extends SIM, and we have mentioned the attribute of Airtel, that is color, and we have also mentioned all the attributes of parent and child. See guys, always you have to mention parent attributes first. We have to first mention parent attributes, then you have to mention child attributes. Okay, and using supercall statement we are mentioning the parent class attributes, and through this we are also calling parent class constructor. Using supercall statement we are calling parent class constructor, as well as we are passing data, to it. Okay, so after this dish dot color is equal to color, the own color attribute we are initializing in the Airtel. Now we shall go for the attributes. I mean the printing all the attributes are, I mean all the variables of your class Airtel. So we can go for sim number colon, we can go for sim number variable. Next, so next we shall go for network type. So we can go for network type variable. Then we shall go for service provider. You go for service provider variable. See, that's all in your class Airtel. That's all in the class Airtel. So after this, in here, we have done sim details method, everything. So class Airtel is finished. Okay. Now let us create class idea. See, everything is same. Everything is same except that it is a idea class. So what we'll do, we will create one more class like this. So we will change it to idea, and constructor also we will change to idea. That's all done. So now you have idea class. So this is a smart book. This is called a smart book. So we have copied the whole class and we have changed the class name and the constructor name. That's it. Remaining everything is same. So we have created two classes, that is your class Airtel as well as class idea. Class Airtel as well as class idea. Now what we shall do is we shall go for the driver class, and we have to okay, so we have a sim. Now we have to go for a generalization. We have two subclasses, that means two child classes we have. We shall go for the generalization. So generalization sim yes is equal to null I will take. So currently there is no sim. Currently there is no sim object. So that is why sim yes is equal to null we are taking. Okay. And what all the instructions will be giving? No, all the instructions should be repeated again and again. So we will be mentioning that inside a while loop, and by default while loop should be true. Okay, by default while loop should be true. So exit variable has been initialized by true. So while of exit variable, and now we will have an option, or we'll ask user to enter your choice. Enter your choice /n1, first option. Okay, so listen carefully. So we're gonna choose the first option now. So the first option will be choose the sim. Second option will be print sim details, and the third option is exit. Okay, so only three options we have given. So whatever the options we have given, no, that we have to take in the form of choice variable se.next int method. It's not mandatory that you have to take the name choice only. No, it's not mandatory like that. Okay, but you will understand. Okay, you will understand that your choosing something here. So we have taken the variable name choice. So int choice variable is equal to dot next int. After that, here we shall go for switch, and we'll be mentioning the choice variable inside the switch. Okay, now let us go for case 1. So case 1 is, okay, case 1 is very simple. So case 1 is we have to go for choosing the sim. Case 1 is we have to go for choosing the sim. Now for choosing the sim, see, we have two sims. We have Airtel as well as Idea. So since we have two sims here, okay, since we have two sims here, we shall go for options. User only can choose which sim user wants. So what we will do here, here also one choice option will give, because when we told to choose the sim, okay, user has to choose either Airtel or Idea. So here we shall go for one more option here, that is we'll go for the sim, that is Airtel, and the second option will be going for Idea. Okay, so this is also a choice. So what we will do is we'll take one choice one variable is equal to se dot next int. And for this, see here, since we had choice here in the line number 12, so we have gone for switch case by taking a choice input. And coming inside here case 1, inside the case 1, here we again have two options. We again have two options. So when we have two options, we are taking a input from user. We have to take input from user, when we have two choices. Now, we have used one switch. Now again, we will use one more switch here. Switch off, choice 1. Okay, switch off, choice 1. And by mistake, don't write choice. Here, don't write choice by mistake. I've seen your seniors, instead of choice here, here also they write the same choice. See what variable name you have given here. Choice 1 or whatever name you have given here. The same name you have to mention in a switch brackets. Okay. So after this, we shall go for the case 1. So we shall go for case 1. And now here in the case 1, if user has chosen Airtel, we have to upcast Airtel to SIM type. We have to upcast Airtel to SIM type in case if user has chosen Airtel. But if user has chosen Idea, then we have to upcast to Idea. You have to upcast Idea to SIM. Okay. So here two options are been shown, that is Airtel and Idea. First option is Airtel. So variable yes, that sim yes is equal to new Airtel of okay, data will give so number. Okay, so Airtel sim number is there. Then we shall go for service provider, right? Network type. Okay. So we have attribute SIM number, network type, service provider, and okay, color. Okay. So here, okay, SIM number we have, network type. We can go for 5G. Okay, and the service provider, that is Airtel. And lastly, the color of the SIM. So SIM color is red and white. Okay, you can take it as red and black also. It's okay. Color, no problem. Color is public, you can take. So after upcasting the Airtel to SIM, after upcasting Airtel to SIM, so we have to go for telling that SIM has been chosen. SIM has been chosen. Okay. Now after this, we shall go for a break. This is just a case one. I'll go for a break. And what if user has chosen case 2? What if user has chosen case 2? If user has chosen case 2, that is idea, we have to upcast idea to sim. So new idea. Okay. So we have to go for number. We can go for 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, I have to mention L indicating it's for null. And coming to the network type we shall go for 4G. And next we shall go for service provider, that is idea. Then after this we shall go for your color of the sim. So color of the sim is yellow. Idea sim, Vodafone sim, they're all yellow color. So okay, so in case user chooses the idea, so we will go for upcasting uh, this idea to sim. Okay, then we will be telling here also sim has been chosen. Sim has been chosen. Okay, so after this you don't have to give break because there are only two cases, and currently we are in one case. Can you see here? Currently we are in case one. This is the case one. Currently we are in case one, and inside one switch block another switch block we have inside one switch we have one more switch. Okay, you can call it as a nested switch also, like this also you can do. So nested loop, when we tell no, we can go for for loop, while loop, do while. Okay, and here nested switch statements we have here. Okay, you can call it as a nested switch, whatever. Okay, so this needed. Okay, why? Because here we have two options, that is Airtel and Idea, and we are using choice one variable. We have taken the input, and if excuse me, if Airtel is chosen, Airtel will be upcasted to sim. If Idea is chosen, Idea is upcasted to sim. Upcasted to sim. So after this, now after case one, see sometimes what happens. No, you will be it will be very difficult and confusing and frustrating to check where is a close bracket for the opened case bracket. So what you do, we'll go for the case one now. Select it. Okay, selected. Now below you can see one box. So inside the box we have one bracket. So here ends your case one. So after case one you can give break. Now we shall go for case 2. So we shall go for case 2 now. In the case 2, in the case 2, we are telling user to print the sim details. We are telling users to print the sim details. Okay. So sim details. See guys, if there is a sim, we can get the details of sim. If there is a sim, we can get the details of sim. So what if the sim does not exist and directly I go to print sim details? What if there is no sim details? Okay, I mean there is no sim present. Okay, and knowing that also, if I go for print the elements data, or print the details of a sim, obviously you should get a error, you should throw an error. So here what's happening is, so here we have case one. Okay, it's done to choose the sim. Now for printing sim details, first we have to check if sim is there or not. If this dot yes is equal to null. So currently, okay, sim yes, we'll just take it as yes only. This not needed. Okay, we'll just take it as yes only. Currently here only it has. Okay. So currently, if yes equal to null, okay, if yes is equal to null, then we will tell that the sim has not been chosen. We will tell to the user that sim has not been chosen. sim has not been chosen, and we'll tell please choose the sim. Okay. So since we have not yet chosen the sim, okay, we have not created any child objects. Until we choose, we will not create any child objects, and after choosing, we will tell the sim has not been, I mean, if the there is no sim object, we are telling sim has not been chosen, and we will tell please choose the sim, please choose the sim. This is when there is no sim object, that is sim is equal to null, the sim variable s, sim variable yes, if it is equal to null, we'll be telling sim has not been chosen. Okay, so what if there is already a sim? Okay, what if there is already a sim, the sim currently now it's in existence. So here what we have to do is, in the else block here, we have to go for if else. Okay, if, whom you have to use now, instance of operator. Now we are using, if the reference variable of sim, yes, if it is an instance of, if it is an instance of class Airtel, that means if he has upcasted to class Airtel, if he had upcasted to class Airtel, then we shall downcast to the class Airtel, and we will print the Airtel details. We will print the Airtel details. So what are we doing here? We are going for if instance of Airtel. So here, excuse me. So here, now what happens is when you're, I mean, if you're having the variable of parent variable is here, and you're having a child object Airtel here. Okay, so parent variable is and a child object Airtel. See, we already know these two have an easy relationship. Since they are in easy relationship, they are already upcasted. So if you want to access the Airtel details method, if you want to access that is print details, print sim details method, this case 2 goes for print sim details method. And in this, and in this, here, here, if there is a sim, if it is an instance of Airtel, okay, that is the sim is a child or object of Airtel. If yes is an instance of Airtel, then we have to downcast it. So how shall we downcast Airtel? So Airtel um A is equal to Airtel of Airtel of yes. Okay, so we have downcasted, and after downcasting, we'll be accessing the all the details of the method, that is your a dot sim details method, a dot a dot sim details method. Okay, so we don't have to print and println, it's a method name, so we can call it directly. Okay, done. So after this, this is the option for choosing the, for choosing the sim. Okay, so here, I mean, which one, I mean, which one is currently chosen? Okay, which one is currently chosen? That sim object, I mean, the sim details will be shown to you. Okay, so this is when, this is when if the instance of Airtel, if S is a belonging to Airtel, then we will be downcasting to Airtel type, and we'll be calling sim details method, sim details method. Okay, now, now here, if you have chosen Airtel, then it will work for sure. It will work for sure if you have chosen Airtel. But in case if you have chosen Idea, okay. So what if you have chosen Idea here? So for Idea, in the else block, in the same case to else block. So here in this else block, we will be checking if it is an instance of your Idea. Okay, so why is that so? Okay, why is that so? So here we don't have to use instance of again. If it doesn't belongs to object Airtel, then it doesn't go anywhere. It does belongs to, it does belongs to Idea. So here only we have put one condition. Okay, here only we have put one condition, that is, I mean, yes is an instance of your Airtel. Okay, so in here in the else block you don't have to again use instance. You can go for downcasting idea. Idea I is equal to downcasting idea, and here we'll have the reference that is yes. And with the help of variable I dot sim details method. Okay, so this is about a case 2, that is check whether there is a sim, I mean which sim object is there, that is sim details should be there. Okay, so yeah guys, we'll resume back. Yeah, consider is there. Yes Varshita, you can carry on.
Thank you, ma'am. Good evening, guys. This is Vashita from announcement team. Am I audible to everyone, guys? Yes, okay. So, guys, here's the testing requirement. So, please take a snap of this, everyone. So, if you're completed manual testing, so you can register for this requirement, guys. So, make sure that within half an hour after completing your class, within 9:30, you have to register for the requirement, guys. So, I hope it's done. So, I'll stop sharing the screen now. So, guys, any doubts regarding the requirements? Okay, so these are the update for the today's class, guys. Thank you, guys. Thank you, ma'am.
Okay guys, we'll resume back. Okay, yes, so we were doing your design, that is yes, the case 2. So if there is no sim object, we will tell sim has not been chosen, please choose the sim. But if sim is already there, we don't know which sim has been chosen. We don't know which sim has been chosen. To know which sim has been chosen only, we have gone for this if and else. Inside else, we have gone for if and else because we have to know which sim has been chosen. Okay. So here in the if block here, we have checked if yes is an instance of Airtel. That means if the Airtel has been upcasted to SIM or not. If the Airtel has been upcasted to class SIM or not. Okay, if it has upcasted to class SIM, then here you have to downcast to SIM class, SIM Airtel class, and you have to get the SIM details method. If SIM Airtel has not been chosen, I mean if it has not been upcasted, if Airtel is not upcasted, if you have chosen idea, control will come to class idea. Okay, control will come to else block, control will come to else block, and here you will be getting, I mean you'll be downcasting idea details from the sim, and you will be going for sim details method of the class idea. Okay, so this is about your design, and this is your case 2. This is your case 2. I'm saying guys. Just a minute. Okay. So okay. So how many cases we have done here? We have done 2 cases now. So we'll go for a break. and we will have case 3, that is case 3, that is exit. So exit variable is equal to true, and we will also tell thank you. Okay, we will also tell thank you for using the, we'll just tell thank you. Okay, so after case 3 we shall go for break, because user might give an options which is not here. Okay, so yes guys, now you guys tell me now what we have to do. We have to make sure user is user should not give a wrong option. So what block we have to create now here? Anyone? Yes, we have to go for default. We have to go for default. Yes, we have to go for default, because we have to go for default because user might give wrong option, and we have to tell invalid choice. Invalid choice. Okay, this is your class sim, and this is your design for understanding upcasting, downcasting, as well as to understand instance of operator. Okay, so let us run it, and we shall go for the console here. So you have to listen carefully. See guys, we have three options: exit, print sim details, choose sim. So what we do is, without choosing sim, first we'll go for printing sim details. What are we getting before going and choosing sim? We are directly going and choosing print sim details. Sim has not been chosen will be given. Sim has not been chosen, and please choose the sim. Sim has not been chosen. Sim has not been chosen, and we will be going for please choose the sim. Okay. Okay. So after this here. Okay, after this here, now we shall go for wrong option. So when you give wrong option, you'll be getting invalid choice. You will be getting invalid choice if you give wrong option. And now we shall go for choosing the sim. Okay guys, now you tell me which sim you have to choose. Now you guys tell me which sim, either Airtel or Idea. Whatever you choose, you will get the details of it. Okay, so first Airtel has been, okay, first Airtel. So what see, we have gone for Airtel here. Option number 1 Airtel. So we have typed 1. So we're getting a SIM has been chosen. SIM has been chosen. Okay. So currently we have chosen Airtel. Currently we have chosen Airtel. Okay. And now if you go for SIM details, we will be getting Airtel SIM details only. Now can you see here SIM number, network type 5G, service provider Airtel. Now can you see here SIM color I have not given. If you want you can add it. SIM color you can take. We'll add it later. Okay, it's not that important. SIM number, network type, service provider, that is Airtel. Okay, so whom we have chosen first? Airtel. So only we are getting Airtel details. Now we can choose one more. Okay, one more time we can go for choosing. So choose the SIM. So Airtel Idea is there. Now we shall go for option number 2, Idea. So as we have chosen Idea here, we are getting SIM has been chosen. SIM has been chosen. Okay. So SIM has been chosen, and now here, if you go for print SIM details, if you go for print SIM details, you will be getting the details of Idea. You'll be getting details of Idea. So second time whom we have chosen? We have chosen Idea. So currently we are getting all the details of Idea only. Okay. If you want to exit, you can go for option number 3. And it will tell thank you, and you have to exit actually. Again you are getting this, just a minute. What happened here? After exiting, you have to not get all those options. Case 3. Okay, okay, I've given true here. Huh? Okay, I have to give false. Okay, so we'll go for printing sim color also here. Okay, so where we are having here. Okay, so sim color also we will have here. Shall go for sim color, that is color attribute. Okay, same thing we have to even mention in one more class, that is idea. Okay, so now let us execute again. Nothing will execute except exit. Exit we have given true, that is why it was we are getting again. So case 3 it will just tell thank you and it will stop. That's it. Now if you choose sim, okay, if you go for I mean you have to run again if you want to go for any other options. So if you want to choose the sim, you choose Airtel and sim has been chosen. If you go for print sim details, then surely you will get all the details of Airtel. Okay, and okay, so now Airtel details you got, and now if you go for choose sim again, if you choose idea, sim has been chosen. You go for print details, you will be getting you will be getting idea details. You will be getting idea details. Okay, if you give wrong input, you will be getting invalid choice. Invalid choice. Okay, and if you want to exit, you can go for option number 3. It will tell thank you and it will take you out of the code. Okay, so this is about a sim design, okay, using which we have done hierarchical inheritance. Okay, we have done hierarchical inheritance, and also we have used instance of operator, and I hope everybody is clear with this design. Everybody understood? Let me know if everybody understood. Okay, guys. In case if you have understood, now let us proceed with some more programs. Programs or line number 21. Na? Void loop. Explain again. Main void loop. What void loop? Void loop. What void loop we have in the design here? What? Who? Okay. Main void is there for the main method. Void is a return type. What is there? Which cases you want? You have to tell me case number. Someone told. Okay, you only told line number 21. Okay, someone told line number 21. What is there in line number 21? Nothing is there. Switch bracket is there. That's it. Yes. All the cases you want me to explain? Any specific case or all the cases? Okay, case one in case one. Okay, fine. So here we have two options. Choose the sim, print the sim details. And if you go for choice, okay, if you go for choose the sim, we will have two options. Case one, that is choose the sim. Okay, so choose the sim is the case one. So case one is here, and in that we have two sims. When you tell choose the sim, we have to give two options, because in the designs we have two sub children or two sub classes we have, that is Airtel and Idea. Okay, we have Airtel and Idea. Okay, now, so Airtel and Idea is there. Okay, next int choice one is equal to AC dot next int, and here we are taking any one input from user, either Airtel or Idea. Airtel or Idea. Okay, so whatever we have taken, we will be passing inside the switch. And if a case 1 has been chosen, 1 has been chosen means obviously it is Airtel. Okay, as you can see here, for the 1 we have given Airtel, for the 2 we have given Idea, for the 2 we have given Idea here. Okay, and and here case 1 is done. Now after that, case 2, if user has chosen Idea, then case 2 will be executed. Either Airtel will be upcasted or Idea will be upcasted to sim type. Okay, either Airtel will be upcasted. At a time, any one class only can upcast. Either Airtel can upcast or Idea can upcast. Whoever has upcasted, let it be. Okay, now coming to case 2 here. Case 2 is print sim details. We are first checking if there is sim or not. Okay, we are first checking if there is sim or not. If there is no sim, we will tell sim has not been chosen, please choose the sim. We will tell sim has not been chosen, please choose the sim. Okay, and in the else part here, we are going with the, we are taking the help of instance of operator. So instance of operator tells which class has been upcasted to sim. We have mentioned sim reference variable, and we are mentioning Airtel. If Airtel has been chosen means here this instance of operator will return true, and when the condition of the instance of operator is returned true, if condition also will become true that time, so you will be downcasting Airtel from sim to Airtel. You'll downcast and you'll call Airtel sim details method. But in case if the sim is not an instance of Airtel, that means if the sim does is not upcasted to Airtel. Okay, if Airtel object, the child object Airtel, if it is not upcasted to sim, then the condition here will become false and control comes to else. Then you'll downcast to sim to Idea, and here you'll be going for sim details. Case 3, exit is equal to false. Thank you. So I'm gonna explain you here why we take choice 1 instead of choice. See, inside the same, see, this is a main method. And this method, inside this method only, we are going for the variables. Sim S is a local variable. S is a reference variable also, but those are local. This S is a local now. Okay, this exit is a local, this choice is a local variable. And in a one method, okay, there should be only one variable with the same name. Okay, one every variable name should be unique. Okay, so we have to take this input also extra, so we have taken choice one variable. If we take choice variable, it will be, we will be giving input to this. So only we have to go for one more variable here, choice one, so that we can take a proper input and store in a proper variable and do execution. Okay, for taking this input, we are going for choice one variable. Okay, with a local variable should not be same. Duplicate local variables you cannot have. In a method, you can have variable with one name only once. Another variables with different name you can have. Same name variables 2 3 times, more than one time it is not possible. Okay, so that is why we have taken choice one. Okay, so anywhere, okay, let me explain you here. The motto of this is, one second guys. Excuse me, guys. There was some background noise. Excuse me. Okay, so let me explain you. Okay, how you are doing this. Okay, so very simple. Okay, so we have two options here. Okay, we have two options: Airtel and Idea. Okay, if Airtel has been chosen means, if Airtel has been chosen means, Airtel will be upcasted to SIM type. If Airtel has been chosen means, Airtel will be upcasted to SIM type, and you will be choosing the SIM only but Airtel. If Idea is been chosen, Idea will be upcasted to SIM. Okay, Idea will be upcasted to SIM type. Okay, now, now using instance of operator, we can check if SIM yes, instance of Airtel. That means if the SIM has been upcasted to, I mean, if Airtel has been upcasted to SIM, instance of operator will return true, and we can take a yes instance of Idea. If the Idea has been upcasted to SIM, this will become true. Say two times using condition, it's a waste of time. So we can just use one time here. So one time we are using, that is yes instance of Airtel. So if this condition is true, which means Airtel has been chosen, and we will downcast. See, we have upcasted no, so we will downcast SIM to Airtel type. We'll downcast SIM to Airtel type, and with the reference of Airtel, we will call SIM details of Airtel class. Okay, and here, if this condition is true, okay, we'll be downcasting SIM to Idea type. We'll be downcasting SIM to Idea type. Idea I is equal to whatever downcasting you will do, and with the help of a reference, you will call SIM details method. So instead of doing this circus, if this condition is true means Airtel is chosen. When you come to else, okay, if this condition is true means Airtel has been chosen. If the condition is wrong here, obviously it is, say, there is only else, if and else. If Airtel is not chosen, obviously it is Idea only. So when it comes to else, which means Idea has been chosen, so we'll downcast Idea. Idea I is equal to Idea of the variable s. So using I dot idea details, I mean sim details method, you can easily call. So this is the logic behind your sim design. Okay, so I hope now everybody has understood. Clear, guys? Inheritance itself is clear. Everything is clear regarding inheritance, this principal inheritance relationship, everything. Are you guys clear? Okay, so we shall go further. Okay, we'll go further, and here, see, can anyone tell me the principles of whoops? Whoops, four principles we have seen. What is first one? Guys, answer the question. What is the first principle of whoops? Encapsulation. Second one, inheritance. Third one, polymorphism. Fourth one, yes, abstraction. Abstraction, yes. So till now we have completed encapsulation, we are done with inheritance. Okay, we have studied relationship has a easy, in easy. Okay, through easy you can achieve inheritance, through easy you can achieve inheritance. Okay, so encapsulation done, inheritance done. Now let us go for our third principle of whoops. We will go for third principle of whoops, that is polymorphism. Okay, see, guys, polymorphism means, okay, let me tell you very simply. Have you guys watched a movie wherein a hero will have multiple character disorder? Have you watched a movie like in Telugu it is called as Gajini, in Tamil it is called as Onion? Yeah, I mean, yeah, sorry. Yes, not Gajini. It's what do you call it as? Gajini is different thing. Like he'll have a multiple disorder, multiple personality disorder. So yeah, that hero. Okay, that hero. Okay, assume there is one person hero. Okay, let's just assume he's a hero, and this hero in the movie he will have multiple personality disorder. Yes, it's aparichit. Yes, yes, personality disorder. In Telugu, it is aparichitudu. In Tamil, it's onion. Yeah, yeah, I remember now. Yes. So if you take the hero, okay, if you take a hero, yes, he will have multiple personality disorder for whatever reasons. Okay, he will have a multiple personality disorder. He is one object. Hero is an object. According to our Java, everything is an object. Everything is an object according to Java. And we have hero object here. Now, hero object here, there is only one object. Okay, there is only one object, but it is exhibiting multiple personalities. There is only one object, but it is exhibiting multiple personality. You can relate with Aparichitudu or Onion, so you can relate with it. There is only one object, one hero object, and you will be having multiple personality disorder. So one object exhibiting more than one form with the same name. Okay, he has same name, but in movie he has taken different. Okay, so here one object. Okay, here the object ability. Okay, this object has an ability to exhibit in more than one form, to exhibit in more than one form with the same name. Okay, his original name is same. Okay, with original name is same, but he will exhibit more than one form. He will exhibit in more than one personality or more than one form. This is called as your polymorphism. This is called as your polymorphism. So if you see exact definition of polymorphism is polymorphism. Polymorphism means polymorphism means polymorphism is the ability ability of an object ability of an object to exhibit exhibit more than one form, more than one form with the same name, more than one form with same name is called as polymorphism, is called as polymorphism. Okay, see guys, actually telling this polymorphism has been derived from the Greek words. Okay, poly means poly means numerous, numerous or many. Morphs means here it's forms. Okay, so here combiningly it will behave as a, I mean it will have a numerous forms, it will have a numerous forms. So polymorphism itself means a numerous forms. And here the polymorphism means it's an ability, it's an ability of an object to exhibit more than one. Okay, I mean it to exhibit in a more than one form, to exhibit more than one form with the same name is called as polymorphism. Polymorphism. Poly means numerous, yes, more than one, yeah. So polymorphism is an ability of an object to exhibit more than one form with the same name, with the same name is called as polymorphism, is called as polymorphism. Okay, and here if you have one name, okay, if you have one name, there will be multiple forms of that name, there will be multiple forms of that name. If there is one variable name, if there is one variable name, we'll have different values, we'll have different values. Okay, if we have one method name, we have one method name, we'll be having different behaviors for that method, different different behaviors for that method, different behaviors for that method. Okay, so it is like if you have a name, one name, you can have multiple forms, one variable names, different values we can have for that variable name, and one method name if you have, we can have a different behavior for that method name, different behavior for that method name. Okay, you'll not understand this now, you'll understand as we learn the polymorphism. Okay, so polymorphism, in the polymorphism we have two types. Okay, in the polymorphism itself, in the polymorphism itself we have two types. We have two types. First one is, first one is compile time polymorphism. Compile time polymorphism. Second one is runtime, runtime polymorphism. Okay, so in polymorphism we have two types: compile time polymorphism and runtime polymorphism. Okay, so so here now let us understand first what is this compile time polymorphism. So compile time polymorphism means, okay, if the binding, okay, binding means in case if you have a method call statement, that method call statement will call one method, that method call statement will call one method. For example, see guys, if you're having one method call statement, no, it will surely call one method. Okay, this behavior is called as binding. Okay, so method call statement calling a method is called as binding. Okay, so it's just one example of a binding. Okay, so if that kind of binding, okay, if the binding is, if the binding is achieved during compile time, if binding is achieved during compile time and same behavior is executed, same behavior is executed, same behavior is executed. Okay, then we call it as a compile time polymorphism. Okay, if the binding, if the binding is achieved at compile time and the same behavior is executed during runtime or during execution, okay, is executed during runtime, during runtime or during execution, it is called as polymorphism, that is compile time polymorphism. Okay, so compile time polymorphism means there are some elements, okay, which are binded to the class during compile time, they are binded to the class during compile time. Okay, and they are binded and it's the same behavior is exhibited in the output. Okay, same output, same behavior will be getting in the output also. Okay, so that is called as compile time. And to understand compile time polymorphism, we have to go for, we have to go for different means wherein we can achieve the compile time polymorphism. See guys, compile time, in compile time polymorphism the elements will get binded to the class, they'll get binded to the class. So we can call this compile time polymorphism also as a, we can call it as a static polymorphism, can called as static polymorphism. Why? Because static members usually they bind to the class during compile time only. Static members usually bind to the class during compile time only. So we call it as a compile time polymorphism, and or else we can call it as a static polymorphism. Compile time polymorphism means if the binding is achieved at compile time, if the binding is achieved at compile time and same behavior is executed, okay, if same behavior is executed, we will be, and same behavior is executed during runtime, same behavior is executed during runtime, then, okay, then we can tell it is a compile time polymorphism, it is a compile time polymorphism. Okay, and yes, yes, yes. We will see what is compile time. We will see. See, this compile time polymorphism can be achieved using four ways. Okay, you can have this compile time polymorphism in a four ways. Okay, so those ways are, your first one, that is you can achieve compile time polymorphism. You can achieve compile time polymorphism by first one, that is method, method overloading, method overloading. Second one, constructor overloading. constructor overloading. Third one, variable shadowing. Variable shadowing. Fourth one, method shadowing. Fourth one, method shadowing. Fifth one is operator overloading. Operator overloading. Okay, since we don't have this operator overloading supported in Java, we will not learn about this. Okay, see, this operator overloading is not supported in our Java. It is not supported in our Java, so we will ignore this operator overloading and we will study this remaining elements. And in this already I have taught you what is method overloading and constructor overloading. Okay, so can anyone tell me what is method overloading and constructor overloading? Can anyone tell me what is method overloading and constructor overloading? Anyone? We have already done this. After methods we have done the overloading part also. For method also we have done, for constructor also we have done. Anybody? Okay, same method name with different arguments is called as, okay, is called as, okay, class name. In a class same method name but different arguments. Okay, yeah, that is a method overloading. Yeah, okay, fine. What is constructor overloading? Okay, same class name but with different parameters. Okay, guys, okay, fine. I agree for this. But what if the constructor name, like if we create a same constructor, I mean a constructor with the same name twice, if we create, or method with the same name with the same arguments twice, if we create, what will happen? What will happen? Yes, you'll get compile time error, but what is that exact error you're getting? What is that exact error name? In case if we create by mistake, if we created same method with the same arguments, or a same constructor name with same arguments, if you have created, there is one error you will get compile time error only. But I want the name of the error. Name. Not constructor duplicate. You will get same error. For method, if you duplicate it, you will get same error. For constructor, if you duplicate, same error you will get, because constructor is also a special type of non-static method. Okay, so whatever you do, that is a method only. In method only now we can do overloading, right? Hmm. See, you will get one error. So that error is duplicate method error. If it is for constructor also same. Okay, if it is for method also, it is the same. You will be getting duplicate method error. Okay, so we have already studied. Okay, what is constructor overloading and method overloading? Method overloading and constructor overloading is already done. Okay, we have already seen what is method overloading and constructor overloading. So next what we will do is, let us study about your variable shadowing as well as a method shadowing. Variable shadowing and a method shadowing we shall study now. Okay, so first let us go for your variable shadowing. Okay, so we shall go for variable shadowing. Variable shadowing. Okay, so when we tell variable shadowing, what is this variable shadowing? Now listen carefully everyone. Assume you have one parent class here and one child class here, and there is an easy relationship going on between these two. There is an easy relationship going on between these two. Okay. Now, we have assume a parent class here, parent, and here we have class child. Is a relationship going on? See, guys, the situation is in variable shadowing. If a parent class and the child class have the same variable name, if parent class and child class have same variable name, then it is known as variable shadowing. Okay, then it is known as variable shadowing. Either it can be static and static or non-static and non-static. So whatever the type of variable you have created in parent, same type you have to create in child. Values can change, but names should be same. Whatever non-static variable you have created here, same non-static variable you have to create here also. Values can differ, but the name of the variable should be same. Okay. So if you take int a is equal to 5. Okay, and here if you take int a is equal to 10, yeah, it's fine, it's correct. This is called as variable shading. So currently we have a non-static variable. Currently we have non-static variable, and now let us take one static. Okay, so you can have both static and non-static, but we're having a as a non-static. Here also you have to have a as a non-static. Okay, so now let us go for a static, that is static int b is equal to 10, and here static we'll go for 15. Okay, static int b is equal to 15. Okay, so here listen carefully. Here parent class variable 5 is there, child class also same variable with same return type only, you have the value 10. Yeah, it's fine. And here if it is non-static, if a is non-static, here also a should be non-static. But if the b is static, here also b should be static, and it should not be interchanged. It should not be interchanged. Okay, so why it should not interchange? Why it should not interchange? Because because here this a and b belongs to this parent class, and this a and b belongs to this child class. Because this a and b belongs to parent class, and this a and b belongs to child class. Okay, so because of this, you should not interchange anything. You should not interchange anything. Okay, so here, okay, here now, how can you tell it's a couple time polymorphism? So we can tell it as a couple time polymorphism. Um, okay, wait. I'll just take the example through your Eclipse only, so that you'll understand in a better way. Okay, we will have an example here. Okay, we'll go for one class. Okay, so we will create one package. Going to src here and going to create a package. So package name will be poly polymorphism. Polymorphism. So under that package we'll create one class. The class name will be driver class. And so first we'll have driver class here, but we have to first create parent and child class. Okay, so instead of driver we'll go for parent only, parent class. Or okay, we'll name it as a child. Okay, we have class child. Okay, so first let us create a class parent. Okay, so listen carefully. Currently, we have class parent. Currently, we have one class parent and we have one more class child. This child extends parent. This child extends parent. Okay, listen carefully. This child extends parent. Now, if you have one non-static variable here, int a is equal to 5. The same non-static variable you should have in child class also. That is int a is equal to, now you can have your own values. You can have 10 also. Okay. And now here If there is a non-static variable here in the parent class, in the child class also there should be non-static only. But you have one static variable, that is static int b is equal to 10. If you have static variable b here, okay, here also you should have the same static variable, same return type, same static variable you need to have, but you can change the values here. You can change the values here. Okay, so in a parent class there is one non-static variable, in a child class also you should have same non-static variable, but values can change. In a parent class, if you have a static variable, and in a child class you will have the same static variable with the same name, okay, but different values you can have. So this is called as variable shadowing. And here, now why we call this as a compile time polymorphism is because the binding here happens during compile time. Binding happens during compile time and the elements are stuck to the class. All the elements which are executing in compile time, okay, which are binded in compile time and same execution is been given in the output, those are the members of compile time polymorphism. Those are the members of compile time polymorphism. Okay, and here now first let us create an object for parent. Listen carefully. Listen carefully, everyone. So parent p is equal to, we are just creating an instance for parent. Parent p is equal to new parent of no argument constructor. Now you guys tell me. So p dot a also I will call, and I'll be calling p dot b. Okay, now can you tell me the output of line number 15 and 16? Output of line number 15 and 16. Anyone? Output of line number. Okay. What is it? 10 15. We have just created an instance of parent class. Yes, Samiksha and Pooja are correct. See, in a parent class we have A and B. We have just created an object for the class parent. We have just created an object for the class parent, and in the reference of using the reference of parent object, you can only access parent class members. You can only access parent class. Excuse me. Okay, you can only have access to parent class members. You can't access child class members. With a parent, you can't access child class. And if you can see, this variable p reference type of variable p is of parent type. So the members of parent only will be executed here. Okay. Now let me create an object for child here. Child c is equal to new child of no argument constructor, and we'll be going for c dot a, and we shall go for c dot b. Now can you tell me the output of line number 19 and 20? Line number 19 and 20 output. 19 and 20 output. Anyone? Line number 19 and 20 output. Yes, it's a 10 and 15. Correct. It is 10 and 15. So why it's a 10 and 15? Because these two members, see, though we have members in parent class, it doesn't matter. Though we are inheriting, it doesn't matter. What matters is what we have created in the child class. What matters is what we have created in a child class. Okay. So in the child class here currently we have the non-static variable a and static variable b. So with the creating an instance of child, you can call the non-static variable as well as static variable. You can call the non-static variable as well as a static variable with the object reference. See, here you are getting a 5. Here you are getting a 10. But here you are getting a 10 and and here you are getting a 15. Okay, now we have just created a classes for separate objects here. Now, since they are having a relationship, since child is having an easy relationship with the parent, now let us go for upcasting. And one thing for sure I have to tell, whatever circus you do, this a is equal to 5 value will store in parent only, and b is equal to 10 value will be storing in this parent only. Whatever do you do, this will not change. And int a is equal to 10 will be uh, present inside class child only, and static int b is equal to 15 has been present in the class child only. Okay. So here now let us go for upcasting here. Upcasting means converting the address of address of converting a child address to the parent address. Okay, you'll be converting a child address into a parent address. You'll be converting child address into a parent address. So already we have an object for C. C is equal to upcasting no. So P is equal to C. So directly we can do upcasting no. Directly P is there, parent P is there, child C is there. So P is equal to C. So parent attribute is equal to child reference variable. Parent reference variable is equal to child reference variable. So actually we have upcasted here. Actually telling we have upcasted, and after upcasting, as I told you, you can access only parent class members. You can access only parent class members. But here, now let me show you. Now, yes guys, now we are upcasting now. Now can you tell me the output of line number 24 and 25? Line number 24 and 25. Can anyone tell me the line number, value of line number 24 and 25? Okay, so when P is equal to C, what matters is what is there in LHS side. Yes, guys, your answer is correct. Sanket's answer is correct. Here, here, the child object is converted into parent type. Child is converted to parent type, and here now currently. So you have to see the left hand side. Always remember, completem polymorphism means you have to see the type of reference variable. Okay. So completem polymorphism means okay, it's always the type of object or type of reference variable. Okay. The type of reference variable P is equal to C, that is instance of child. All address is stored in the variable C. Now when it is P is equal to C, upcasting is done. That is converting the child reference into a parent. Okay, converting a child into a parent. Okay, so this is what we call upcasting. Even after upcasting, you will not have any change in the values. Okay, so here we are going for P dot A and a P dot B. So P, okay, P, what is it having? 5 and 10. So you will be getting 5 and 10 here. Okay, so let us execute here. Okay, what we have here? So first time 5 10, next 10 15. Now again it's a 5 10. Again it's a 5 10. That means it's a proper output. So upcasting, we are converting child reference to parent type, and here. So P dot A means you will be calling only the parent members, parent class members. Okay, and here P dot B is also a parent class members. P dot B is also a parent class members. So here the members, okay, the starting members especially are binded to the class. Okay, and Here now currently upcasting is done. Though we have upcasted, the address of child will be changed to this the all the I mean the child object itself has been changed to parent. Okay, you already know upcasting. So though upcasting is done, depends on the reference type. Always remember compile time polymorphism, it depends on the LHS side. Okay, that is the right side of your hand. So here, I mean for us it's a left. Okay. So here P is equal to C, upcasting is done. Though we have done upcasting, we'll be able to access parent class members only. Next, if you do downcasting, if you do downcasting, okay, so if you do downcasting, now we shall go for C is equal to child of parent P. Here we are doing downcasting and with the help of the reference C dot A and C dot B, now I want you guys to give me the answer here. So what is C dot A and C dot B? Okay, think properly. Think again. Okay, 10:15 only. Yeah. Yes, it is 10:15 only. Why? Because I already told you the output of the completed polymorphism just depends on the reference of the type of object. Okay, what is the type of object? Okay, based on that only, now you'll be getting the output. So it is P here, that's parent. So you'll get you're getting parent class members. So it's a C here, that means it's a child. Okay, which means it's a child here. Okay, now for the child here, now using the child reference, you can access only the child class members. You can access only the child class members, that is 10 and 50. Okay, so this is about your the compile time polymorphism and your here variable shadowing. Okay, variable shadowing has two it has two types. I mean, two types of variables you can use, that is non-static and a static. The rule is if a parent has a non-static variable, a child will have also the non-static variable with the same name. Name also should not be changed. But if you have a static variable in a parent, you should have same static variable in child class also. Okay, see, if parent is having static int b is equal to 10, so child class also should have static int b is equal to values are personalized choices. You can go for 15. So the current output here is 10 and 15 only. 10 and 15 only. You have to, in the compile time polymorphism, first you have to check, excuse me. So in the compile time polymorphism, first you have to check the LHS side. Okay, that is the type of reference. Okay, type of reference. So once after knowing type of reference, you can easily get to know what is the output. Okay, so this is how you'll be doing upcasting and downcasting using a normal way of doing it. Okay, voice is breaking. Guys, is my voice is breaking, everyone? Okay, guys, thank you. Yes. So we have seen a variable sharding. Variable sharding is very simple. If parent class and child class have same variable's name, either it can be static or non-static. It can be both static or non-static, but with a same variable name is called as variable shadowing. Is called as variable shadowing. Okay. So in the variable shadowing, we had learned even though we upcast or if we downcast, you will still get the same members. Okay, so where is it used? So practically speaking, it is used in softwares like there is some constant values. Okay, for every object in every program, every design you can use this. See, sometimes what happens, you need to have the attributes also, but along with that you need to have a specific value prefixed for a class. There should be one value for that class. Same, though we have same variable, but we can't have same values. Okay, you can have same values also, but there will be no uniqueness in the element. So here, if in every object, okay, see, suppose if you take a height, or if you take a anything, like if you take a height, for this parent object it is different, and for this child object is different. It is of height only, okay, if it is of height only, but it differs for parent and if it differs for child. The where you will write here is, suppose if you are creating a design wherein parent and child class should both have the variables, okay. Parent class members only, child can't inherit and it can initialize, no, child also should have its own members. So because of this, and one more thing is, here here you can easily change the values here and you can access it. In a comparative polymorphism, always remember you have to just see LHS side. Okay, you have to just see LHS side, and you will be getting to know who has been static who has been done polymorphism, you'll get to know. Okay, so in upcasting, though we have done upcasting, still we are able to access the parent class members only. Okay, though we have done downcasting here, okay, we are able to achieve this downcasting members by just getting the output 10 and 5. Okay, so this is about your variable shading. So any doubts you have? So where it is used means everywhere in the program it is used, man. See, parent and child should have some uniqueness. So data will be different of every person. So same variable name should be there, but data will be different. See, problem is, if you have a non-static variable, usually what happens, it will be available in child while inheriting. While inheriting, it will be available with child, and with the same value, it will be available. So we don't want that. We need to have something uniqueness in this. So here, one parent class have variable int and, int and static. Here also it has int and static. Okay, so what if we do upcasting and downcasting, then output not change, then why we do here, but we do upcasting and downcasting, the output not change, then that is what we call no compile time polymorphism. Yes, that is what we call it is completum polymorphism. Then how you name this scenario? How do you name this scenario, and how do you name this behavior now? What is this called as completum polymorphism? To understand what is runtime polymorphism, it will take some time. But completum polymorphism, we have variable shading and method shading. Method shading we'll see in tomorrow's class. Okay. So till variable shading you have you can have a parent class and a child class. Okay, in parent class you can have the members, in child also you can have members, and here same variables. Okay, whether it's a static or non-static, you can have same variables, but you can't take the you can't inherit the attributes or the attributes and well as values here. Okay, okay, hope you have understood. Yes, Saurabh, got it. Upcasting and downcasting we are doing here to make you understand that whatever you do, it will not change. Okay, whatever you do, it will not change. That is what we call it as a compile time polymorphism, and it got binded in the compile time, and it will never change during runtime also. It will never change the exhibition. Uh, the what we call it. Um, so here we have to know if the compile time polymorphism is working or not. Okay, so that is why we have gone here. Okay, so we have node method overloading, constructor overloading, variable sharding also we have done. Okay, so that's it, and we shall also go for method sharding with the same example. We will see what is method sharding or not. Okay, so that's it for today. Any doubts for today, guys? Anywhere any doubts you have, you can let me know. Yes, yes, I will send it. Yesterday I was sending, it was not going, maybe because of network issue. What I have been sending it from past half an hour yesterday, but it was not going. I don't know what happened. Maybe network issue. I'll look into it and I'll send it. Okay. Yeah. Oh, okay, okay. Syllabus also. Yes, guys, I forgot. Okay. Yeah, yeah, yeah. 3 days pending. 3 days pending notes. 3 days pending. No, I have sent you the design, right? One design we have done, including has a ease and encapsulation. That design I have sent. Except that we have this thing. Yeah, today considering. Okay, okay. I will send now itself. Don't worry. Okay, guys, that's it for today. And I'll see you guys in tomorrow's class. Okay, and we will also study your method sharding also. Okay, so that's it for today, and I'll see you guys in tomorrow's class. Have a great evening. Take care, guys. Bye bye.